Okay. Let's start with 3-9. You guys are getting better about doing your work, which is good. All right, let's talk about country demographics. So here we've got a table comparing two countries, A and B. We've got population, land area, infant mortality, and net migration. Now, the question is asking us to kind of compare and contrast and decide which one is more developed than the other. Now, population has nothing to do with whether a country is developed or developing or least developed. In fact, there are lots of countries out there that have tiny populations and are considered among the wealthiest countries in the world. There are also countries that have big populations and are developed, right? Like the United States. There's also countries that have big populations and are developing. And then there's the middle, right? Where populations are relatively large, but countries are considered least developed. Just to give you an idea, Norway, for example, is a very developed country, probably one of the wealthier countries in the world. And their population is probably pretty comparable to the state of North Carolina, right? So population doesn't equate to development. Neither does land area, right? Some countries are incredibly large and some countries are incredibly small, but again, doesn't necessarily allude to whether or not the country is developed. Now, infant mortality rate most definitely can, right? Countries that have high infant mortality rates are usually not considered developed, because if they've got a lot of babies dying, that indicates to us that their healthcare is failing to meet the needs of prenatal healthcare for pregnant women, delivery, and then dealing with postpartum situations, or even just taking care of the child in general. And so most definitely country A would be developed or more developed than country B, because the infant mortality rate is much lower. Now, migration rates can be used, right? So generally people leave areas where there's not a lot of socioeconomic opportunity, where they might even be environmental refugees. So that tells us that a country could be struggling. But that's not always the case. Infant mortality is a much stronger indicator of, or indirect indication as to the quality of healthcare that those countries have. So we have another question here. A country with like a declining death rate. So they had a birth rate of 35 per thousand, which you could also represent as a percentage if you want, which would be what, 3.5%. Death rate of 13 per thousand, right? So these are crude birth rates and death rates currently. Now the death rate was 37 per thousand in 1950, and it's been decreasing. Okay, which of the following statements best explains why? Well, more than likely, this country is in stage 2. Now, why would I make that assumption? Because, well, the birth rate is still high, right? The birth rate hasn't changed much, right? And we know that in stage 1, birth rates and death rates are usually comparable. And then as a country moves from pre-industrial into transitioning, first thing to drop is the death rate because of access to sanitation, healthcare, and medicine, right? So number 2 would be the best answer there. In a certain country, the birth rate is high and the death rate is high, and we've got a lot of children in the workforce, right? So what stage of demographic transitions might this be? Well, if you got a high birth rate, you got a high death rate, and a lot of children are working, this is probably pre-industrial, right? This might be even an agrarian society, and this would be stage 1 for sure. Because usually in stage 2, again, the death rate's falling. In stage 3, culture is finally catching up to technology, and the birth rate would fall, matching the death rate eventually in stage 4. Okay, so stage 1, high birth rate, high death rate. Stage 2, death rate drops. Stage 3, birth rate also drops. And stage 4 would be where birth rate and death rate are again similar, and they're going to be lower, right? And we call those, stage 1 is pre-industrial. 2 is usually referred to as transitional, because you're transitioning from a pre-industrial socioeconomic structure to a tradition or industrial, which would be stage 3. And then stage 4 would be post-industrial, kind of what we are here in the United States. And then eventually they're kind of like, considering a new stage 5, which would be, a declining population like we see in Italy and in places like Japan. Okay. All right. So let's do some calculations. We're going to do some math today. All right. And so let's start with population density, right? So how do we calculate population density? All right. Let's keep it with the darker red. I think it's just easier to see. So we're just going to be really working on the formulas right now. Okay? Population density, to calculate population density, you take population and you divide it by area. And this can be a very valuable tool, because I use 2 countries here, Nigeria and Brazil. Both are in the top 10 most populous countries. And you can see their populations are very similar. But if you look at the land area of those countries, you notice that there's a big difference. So we can calculate something like population density And this might be useful in evaluating density-dependent factors like resources. What is the water availability, arable land availability? What's the space, right, per person? So to do this, we'll take their population, and later on in the semester, I'll teach you guys, or we'll work with scientific notation. It just makes the calculations that much easier, right, to work with. But for now, we're just focusing on applying data to the formulas. So we got a population of 213 million and a land area of 350,000 square feet, okay? And I'll run that calculation here in just a second, okay? So that's for Nigeria. And then for Brazil, we've got 212 million people. And we got 3 million square miles, right? So Brazil is obviously much larger than a country like Nigeria. And let me go ahead. I thought Zoom had a calculator, but I'll just pull up. Oh, where is it? There we go. Wait, where'd it go? All right. So we've got, let's do this. That way we can have both up at the same time. Sorry, I'm not the most tech savvy person. All right, so we've got our population, 213 million. Okay, and we're gonna divide that by 350,000. And what is our population density? Looks like about 609. 609. Oh my goodness. You know when it rains, it pours. All right, here we go. 609 people per square mile, right? You can write that as people per. You can do this, or you just simply write the word per square mile. Okay, let's do Brazil. And we know, right, just our intuition is telling us that the population density is going to be much smaller, but how much smaller, okay? So we've got 212, 1, 2, 3, 4, 5, 6, divided by 3 million. What do we get? 71, right? Now, this is a good indication as to what the resource availability per capita, remember per capita simply means per person, the disparities, the differences, right? So obviously in Nigeria, at a certain point, there might be issues with resource availability. They might have to import more resources than, say, a country like Brazil, which has a much lower population density, okay? Now let's go over here and let's do some calculations for birth rate. So we've got births in a year and deaths in a year for both Brazil and Nigeria. And so to calculate birth rate, it's just births divided by the total population. And if we're going to represent this as a percentage, right, we need to take this decimal and we need to multiply it by 100. So for Nigeria has 8 million births, we need to divide that by the total population, which was 213 million, okay? And then that'll give us a decimal, multiply that by 100, and that'll give us a percent. And then we'll do it for Brazil as well. 13 million, 212 million. And again, our intuition at this point is telling us that, okay, I know the birth rate's gonna be much higher in Nigeria than in Brazil, but how much higher, okay? That's the question. And again, the percents are really valuable tools and demographics. All right, so let's do our 8 million. 6. And we'll divide that by 213 million. 1, 2, 3, 4, 5, 6. And we get 0.0375. Now remember, this is not the end all be all, right? We need to convert this into a percentage by multiplying it by 100. And we have about 3.8%. So our birth rate in Nigeria is 3.8% approximately. Okay, let's run our calculations for Brazil. 1, 2, 3, 4, 5, 6, 3 million and 212 million. What do we get? Our decimal, we need to multiply by 100 to make sure to convert it to a percentage, and we've got 1.4 approximately. 1.4%. So we can see that the birth rate in Nigeria is well over double that of Brazil. Okay. Now I do need to hang on to these numbers, so I'm going to type them in the chat really quick. 3.8 and 1.4. 3.8% B rate for Nigeria and 1.4% birth rate for Brazil. Okay, let me go ahead and clear my drawings. And we'll move down to death rate. Oh. All right, here we go. Okay, so death rate, pretty much the same, right? So to figure out death rate, we'll take the total number of deaths in a year, and then we'll divide that by the total population. All right, and we'll take that decimal, same as we did before, multiply it by 100. So in Nigeria, there were 2,300,000 deaths for a total population of 213 million. And then for Brazil, there were 1,200,000 deaths for a total population, or in a total population of 212 million. Okay. And before I get carried away, let's not forget that after we do that division, we need to multiply by 100. All right. Now, looking at this, again, our intuition is telling us, okay, the birth rates in both of these countries are far greater than their death rates, right? So there's still going to be some growth in both of these countries. Nigeria, let's go and do Nigeria first. We got 2,300,000, 1, 2, 3, divided by the total population of 213 million, 1, 2, 3, 4, 5, 6. Okay, we get this decimal, we need to multiply by 100 to turn it into a percentage. And we have about, let's do 1.1% death rate. Okay, now let's look at Brazil. And you obviously know it's going to be less, but how much less? 1,200,000. Yep, and divided by 212 million. Just making sure I got enough zeros there. Okay, we get our decimal, multiply by 100 to get our percent. Wait, oh, I didn't do that right. My apologies. Give me 1 second. And 212, 1, 2, 3, 4, 5, 6. Okay, there we go. And multiply by 100. Okay, I did do that right. And it looks like we got a percent of 0.6 would be the death rate in this country. So, half that of Nigeria. Now, if you think, okay, wait a minute. If Nigeria's birth rate is way over double of Brazil, and their death rate is double, does that mean that, it's slower, faster? Well, let's actually calculate the natural growth rate, because this will give us the actual percent growth rate for that country, considering just births and deaths. So anytime you see like natural growth rate, we're generally kind of ignoring immigration. Right? We're not considering immigration or immigration, individuals leaving and exiting a country. All right. And so for natural growth rate, it's really easy. Once you have birth rate and death rate, you can simply take the birth rate, which we already calculated, and you could subtract the death rate, right? Percents, and then boom, you're going to have our natural rate of growth. Okay, so our birth rate for Nigeria was 3.8%, and the death rate was 1.1. For Brazil, the birth rate was 1.4, and their death rate was 0.6, right? And so we can quickly calculate the growth rate. And so for Nigeria, we're going to have what, 2.7, right? So 2.7% growth rate. And then for Brazil, what would that be? 0.8%. okay? Now, we need to ask ourselves, right? What is replacement level fertility? And so you can see that Nigeria is above replacement level fertility. So this country is definitely going to be growing. When you notice about Brazil, it's a lot less, right? Now, these numbers, not necessarily accurate, right? I just kind of grabbed these numbers just for the sake of our calculations today. Now, what else can we do with this natural growth rate? Okay, so we got, make sure to save these for our next problem. I should be able to remember them, 2.7 and 0.8. Okay, scroll down and we can calculate something known as the doubling time, right? So how long will it be before these populations double in size? And we call this the rule of 70. So you just take 70 and you divide it by R, right? The natural growth rate or the growth rate we calculated earlier. And so for Nigeria, we would do 70 divided by 2.7, right? And then for Brazil, we do 70 divided by 0.8. This will tell us the number of years that will be needed for this population to double in size. And for human demographers and for family planning programs and just for countries in general, this can be a pretty good approximation. Now, this is not necessarily accurate because it's assuming that the growth rate is going to maintain or stay the same over the next couple of years. And we know that's not going to be true. Okay, so we'll take 70 and we'll divide it by 2.7. Okay, so 26 years, right? So the population in Nigeria will double well within our lifetime. 26 years from now, there may be, close to 450 million people in Nigeria, which would mean that the Nigerian population would surpass the US population, right? More than likely, because the US population, more than likely, is going to be sitting somewhere at or around replacement level fertility, right? So, and if we reduce immigration, obviously our population will decrease much faster. And so let's calculate, I'll put years, the doubling time for Brazil. Okay, so we do 70 divided by R, in this case, 0.8. Okay, and we get 80, 8 years, right? And so not within my lifetime, sorry, y'all, I'll be hopefully worm food. I don't know if you guys have seen those companies that you can actually be cremated and they take your ashes and mix it in like a peat block and plant a tree in it, right? And so instead of taking your nutrients to the grave and boxing them up and selfishly keeping all of your atoms and elements to yourself, you can be broken down and returned to nature, and your nutrients can then rejoin the biogeochemical cycles, if you will. So, Brazil, it'll be a long time before their population doubles, right? And so you can see and you can understand how environmental problems for these two countries are going to be different, right? Fossil fuel consumption, meeting their energy needs, available fresh water, all of these issues are going to be different for these countries because of the growth rates, okay? Now, there is another calculation that we'll use, and we'll probably use this one more so for like smaller populations, right? Let's say you're monitoring, let's say you work for the National Park, Forest Service, Fish and Wildlife, and you're monitoring a population of mountain lions, right? And you want to figure out, has the population changed over a period of time? And so for population time, we do births plus immigration, right? So things that are going to add to the population. And we're going to subtract deaths and immigration, right? Individuals exiting the population. And that'll give us population change. And I'm going to write P delta, right? This triangle is delta, right? And we use that in science. It's like change. Instead of writing population change, you can just write P delta. Okay. So let's say you observe a mountain lion population over the course of a year, right? And you've recorded some data. Let's say that 20 mountain lions were born. And immigration, obviously there are different groups of mountain lions, populations that are isolated, and there is migration. But let's say, for this sake, that we've introduced some mountain lions. Let's say we've introduced 5 mountain lions into the population. Let's say 10 mountain lions died this year, and then immigration. Let's say maybe 2 of the mountain lions just would not stop, prowling around campsites and getting into trash and like hanging out in the roads and stuff, and you just knew it was going to be a problem. So you captured them and maybe re-release them somewhere else. So they've left this population. So to calculate the change in population, we do births plus immigration, right? So we've got a gain of 5. And then we do deaths, right? 10. And then we remove 2 mountain lions. So we got a loss of 12. And so we do 25 minus 12. So we got a change of 13 individuals, right? This population grew by 13 individuals this year. And what we can also do with this number right here, the number of the change, is we can calculate something known as percent change. Let's say that the initial mountain lion population, right, your starting population was, and I'll use N0 for the number of individuals at time 0, right, at the beginning of the year. And we know that there's 13 more, right? So our population after 1 year has increased by 13. And, you know, if we wanted to figure out like, okay, what's the percent change so that we can make predictions about the future, it's a really easy calculation. So percent change, and we're going to use this formula over and over and over again for lots of different applications, right? Percent change is, right, your initial, or sorry, your new number, right, minus the old number divided by your old number, right? So in this case, you know, what you started with, your starting population and your new population, right? Your old population or your starting population and your new population. And then once we do that, we need to multiply it by 100 to get a percent, okay? So if we do ours, you know, our new population was 213, our old population was 200, divide that by 200, and then obviously we need to multiply it by 100 to get that percent change. And so that's what, 13 divided by 200, we get 100, 6.5%, right? So that would be the percent change. The population changed by about 6.5%. And then we can think to ourselves, okay, what if this were to continue at the same percent change for the next coming years? You could start to kind of figure out, okay, what about after 2 years, after 3 years, after 5 years, and so on and so forth. Okay, well, that's all I have for the math. We're actually gonna have a little practice quiz sometime next week just to help you guys, you know, practice applying, you know, our data and our formulas. But now I want you guys to focus, I want you to use the rest of our class time on collecting your demographic data and preparing for our discussion on Monday. What is the focus of our discussion on Monday? Well, on Monday, we're gonna be talking about family planning, okay? Everyone's chosen different countries, and each of these countries are going to have different total fertility rates. Some of your countries might have really high TFRs, which means there's probably a really rapidly growing population. Some of you guys probably have really low TFRs. Remember, if the TFR, the total fertility rate, the total number of babies born per woman, is less than replacement level fertility, which is usually around 2.1, that population is going to be decreasing. Now, family planning doesn't mean that these programs are always geared towards reducing family sizes. In some countries, there are family planning programs and government programs that have started to try to increase the population. So what I want you to think about is your country focused on, or do you think your country is focused on decreasing the total fertility rate or increasing it? And what I want you to do is I want you to think, and I want you to develop your own program or your own plan, right? So you are going to represent an individual from your country. Say I'm representing Nigeria, right? What do I think could be done in Nigeria to decrease the total fertility rate? What if you represent Japan? Well, Japan's got a completely different situation, right? In Japan, the TFR is below replacement level fertility and their population is shrinking, right? And so if you represent Japan, what could you do to increase that total fertility rate? Because having a really high TFR and having a really low TFR can be both problematic. Having a really high total fertility rate, it's like, how are we going to support the growing population in the future? The same problem kind of exists for a country like Japan, right? How is the shrinking working class population going to support the growing elderly population, right? So struggles there. And what I've included are 2 really short videos to kind of give you an idea. The first one right here focuses on Bangladesh. Bangladesh had a really, really high total fertility rate, and their family planning programs have significantly reduced it. This video right here is about Japan and how the Japanese government is employing programs to try to increase the fertility rate in their country, to try to encourage people to have babies. So on Monday, I'm going to split you guys into 2 groups. I'm going to put the countries who need to formulate and construct plans to increase their fertility in one group. And then I'm going to put the other countries who have high TFRs, who are maybe geared towards decreasing the total fertility rates, into one group. And you guys will kind of collaborate and come up with a plan. Now, there is no such thing as a universal plan for anything really, because every single country is going to be significantly different. So a family planning program that works in Nigeria might not work in another country because of differences in economic development, per capita income, or even something as simple as religion, right? So you'll collaborate and try to come up with a good general idea, but also not necessarily neglecting the small differences that might be needed for certain countries. And then we'll come together and we'll collaborate and we'll talk about, what are some pros and cons of certain family planning approaches? What do we think as a class would be the best way to decrease the TFR, to increase the TFR, obviously depending on the situation. And we'll also talk about family planning in America, right, in the future of our country, okay? So, that's all I have for today. And definitely over the weekend, I know it's going to be a little rainy, but set some time aside to get outside, right? I mean, it's just a little bit of rain. As long as it's not thundering, put your raincoat on, obviously dress warm and go out and explore a little bit, right? You'd be surprised how active nature can be even during a rainstorm, right? I think a nice quiet walk in the rain, I always find soothing, and I'm always surprised by how active all the animals are, right? But again, make sure to dress appropriately. When I was in Norway, some of the locals shared a really interesting saying with me. In Norway, they say there's no such thing as bad weather, just bad clothing, right? So, and I agree. I don't think there's anything as bad weather, right? Just bad clothing and maybe a bad attitude. Well, I hope you guys have a wonderful weekend. If you have any questions about anything, please don't hesitate and send me an email or a reminder.